Hi, sixth graders. We are still on our Unit 7 unit, which is Intro to Algebra and Equations. And this topic is multiplication equations. So we are going to solve equations that involve multiplication. So if addition reverses subtraction and subtraction reverses addition, what will reverse multiplication in an equation? And we talked about this for a second in the last video. But we know that the opposite of multiplication is division. So now we have the division property of equality. And this tells us that if you divide each side of an equation by the same non-zero number, the two sides will remain equal. So remember, if we added or subtracted the same number on both sides of an equation, it kept the equation the same. Now we're doing that for division or for multiplication. We're doing the opposite. So make sure you have division property of equality, and you can just write, if you divide each side of an equation by the same non-zero number, the two sides remain equal. And then I want you to remind yourself of the word coefficient. So write the word coefficient down, which is the numerical factor for a multiplication expression. So the coefficient is the number in front of a variable, and that might make more sense to you. The number in front of a variable, meaning these right here, all of these numbers, the coefficient is the number attached to it. Because there's not an operation in between it, and we've talked about this before, if you have a number with a variable, it just automatically means multiplication. So the coefficient for 3g would be 3. The coefficient for negative 2g would be negative 2. The coefficient for 7g would be 7. The coefficient for g would actually be 1, because I know that I can multiply anything by 1 and get that number. So then the coefficient for negative g would be negative 1, because anything times negative, a positive times negative, I should say, is going to make it negative, and negative 1 will keep it the same number but change the sign. So you might want to refresh yourself and have some examples. Actually, I would say to write those examples down in your notebook. All right, steps for solving one-step equations. You wrote these down in your addition and subtraction video that you watched the other night. So if you did not write them down, then you should, or you need to write them down now. But if you already did, maybe go back in your notes and make sure you have them. Put a little star by them, so that you can thank yourself for writing them before, and now you don't have to rewrite them again. But remember, we write the equation, draw the slide, use the inverse operation, solve for the variable, and then check, which checking is one of the most important parts of solving an equation. All right, let's do some together. So just like last video, you're going to do all of these with me. First, we have 4x equals 32. So 4x equals 32. I write my slide. This time I ask myself 4 times what number equals 32. Again, we can do some of these in our head. We know that 4 times 8 equals 32. But if we don't know it, or if it's a decimal, or if it's a fraction, we don't want to sit and try a million numbers. We want to look at it by doing the opposite to quickly get to our variable. So we know that the opposite of multiplying times 4 is dividing by 4. So I'm going to divide both sides by 4. Remember, that line like that underneath a number means division. So 4 divided by 4 is 1, which is the point. We want to get to 1 because 1 times x is itself. So in addition and subtraction, we wanted x plus 0 or x minus 0 because then we got x alone. Okay? Now here on these problems, we want 1 times x. So we need a 1 in front of it in order to get x alone. If we have a 0, 0x is going to get us to 0, and that doesn't get us to x. So that's why we want to divide by itself to get rid of it to get to 1. Okay? Just like here, we don't want x plus 1 because then we don't have x alone. We want it So it depends on what the operation is, if we need to get to 0 or 1. All right, so 4 divided by 4 is 1, and on these, I do cancel it out so that I know that that's gone, and my x is going to carry down. And then I know 32 divided by 4 is 8. And then, just like last time, we have to check. So 4, oh my gosh, sorry. 4 times 8, does it equal 32? It does. So go back and circle x equals 8. All right, negative 5x equals 55. Do my slide. Same start as all the equations. I always start with my slide. Here I divide both sides by negative 5. This negative stays with the negative, or stays with the 5. That all goes together. We want to get rid of it. So positive, negative, whatever it is, we want to divide by the whole thing so we can get rid of it. So then I do negative 5 over here. And I'm doing negative 5 because that's the one attached to the variable. That's the one that I need to get rid of. So that cancels out because it makes a 1. So x equals, and then 55 divided by negative 55 is going to be negative 11. Then we have negative 5 times negative 11, which, yes, it does equal 55. So x equals negative 11 is my answer. 3x equals negative 27. Divide both sides by 3. Carry that down. Really what that is doing is 1x, and then negative 27 divided by 3 is negative 9. So x equals negative 9. You can do it this way to x it out. You can do it this way. You can do it both ways, as long as you have all of your steps and that you get to your answer and that it's circled. And then underneath, you should always have your check. So 3 times negative 9 does equal negative 27. So then we have it circled and we're good to go. All right, do these 4 on your own and come back and check. 6m equals negative 12, so divide both sides by negative 6. M equals 2, because a negative divided by a negative is positive. Negative 6 times 2 is negative 12. Yes, that works. So m equals 2. Negative 48 equals 8h. So this time I have to look over here because my variable is on this side. Divide both sides by 8. Cancel that out. I forgot to cancel that out over here. Negative 48 divided by 8 is negative 6. Remember, our positive and negative integer rules apply, so we have to think of that. Negative 6 equals h. Same as before, we're going to flip it around so our variable is on the left side. H equals negative 6. Then I'm going to rewrite it exactly how it was up above. Negative 48 equals 8 times negative 6, which is negative 48. So then I end up with negative 6. 6 equals negative 18f. So divide both sides by negative 18 because negative 18 is attached to f. Even though we're thinking, no, we divide it by 6 because that's the smaller number. Whatever number is attached to f, that's what we divide it by. That cancels out, makes it a 1, so we're just left with f. 6 divided by negative 18. So if we think of that, we can divide it. We can like do our division, 6 divided by 18. Or, I'm going to do this in a different color. If I have 6/18, I know that that simplifies to 1/3. And just because if there's a negative sign on the, like just one negative sign, it really doesn't matter where it is. It still makes it a negative fraction. So then really it's going to be negative 1/3. So then I'm going to rewrite it as f equals negative 1/3. And you can write it as 0.3 repeating. That's fine. Negative 0.3 repeating or negative 1/3. So now let's put it back in. 6 equals negative 18 times negative 1/3. Remember when we multiply by a fraction, then I would make this just over 1. And I know that negative 18 times negative 1 is just going to be 18. 1 times 3 is 3. 18 thirds equals 6. So then 6 does equal 6, so F equals negative 1/3, which makes sense because I have negative 18 times something to get 6. So the number I'm multiplying by has to be less than 1 in order for me to get a smaller number. So remember to always check to make sure that it makes sense and that it's reasonable. If you got F equals 3, well, negative 18 times 3 is way bigger than 6, so that wouldn't make sense. And then 17x equals 51, so divide both sides by 17, and I know that x equals 3. 17 times 3 equals 51, so then x equals 3. Okay, we have a couple word problems. Mrs. Acosta's car can travel an average of 24 miles on each gallon of gas. Write and solve an equation to find how many gallons of gasoline she will need for a trip of 348 miles. So we're going to write our equation. We know that it's 24 miles on each gallon, and we want to know how many gallons. So 24 miles per gallon, we want to know how many gallons is going to get us there for our 348 miles. Because we know that every gallon we go, we need to multiply it by 24 miles. And if we have 348 miles, that's a lot for us to figure out how many gallons of gas are we going to need. So then I'm going to do my slide. I'm going to divide both sides by 24, not 25. And you could even write a little division like that. Or, which I don't know why I just wrote it like that. Either one works though. Or like that. And then I know that G, and if I do 348 and I divide it by 24, so I know the answer, but we're going to practice our division. So I know that 24 goes into 34 one time. 1 times 24 is 24, so we have 10 left, which does not go in there at all. So I have to bring down my 8. 24 goes into 108 4 times, because I know 24 times 4, 16, 8 is 96. And then 108 minus 96 is 12. I have to add a 0, bring it down, but because I had to add a 0, I need to write a decimal point here. 24 goes into 125 times, because 24 times 5 is 120. So 5 times 24 is 120, which is 0. So my answer is going to be 14.5. So then we would check it. 24 times 14 and a half. Check to make sure that that works, which it does work. So then what is it asking us? How many gallons of gasoline will she need for a trip? So this is going to be 14 and a half gallons, not miles, gallons, but we always want to include the correct label. If there is a label that needs to go with it, we include the label. So that makes sense. 24 miles, 14 and a half gallons will take us 348 miles. All right, and then the tortoise is one of the slowest land animals, reaching an average top speed of about 1/4 mile per hour, or 25 hundredths. At this speed, how long will it take a tortoise to travel 1.5 miles? We are asked to find the time t it will take to travel a distance d of 1.5 miles at a rate r of 0.25 miles per hour. So we want to figure out how long is it going to take him. So if he's going 0.25 miles per hour, and we want to know how long, so times t, to get him to go 1.5 miles. And we'll put our labels in later. So then we do our slide. We divide both sides by 0.25. That's going to cancel out. I know that 1.5 divided by 0.25 is 6 because I know that 0.25 times 4, like 4 quarters, times 4 is 1. And then I just know that I need 2 more quarters to get to 1.5 or $1.50. We can kind of think of it as that. So T equals 6. And then 0.25 times 6, which we just kind of talked about, like 6 quarters would equal $1.50. So then T equals 6, and again, what is it asking us? Let's go back just to make sure. It says at this speed, how long will it take a tortoise to travel 1.5 miles? So we know that it's going 0.25 miles every hour. So it's going to take him 6 hours. That is a really long time. All right, make sure you have all these wonderful notes for class tomorrow. Have a great night.